Hello everyone. In our previous video, we discussed momentum and impulse, which basically explains why when you jump from an elevated position, you have to bend your knees, or when you punch a wall, you feel less pain if you are wearing a glove as compared to using your bare hands. Today, we're going to discuss conservation of momentum, and we will be dividing this one into two parts. The first part is about the conceptual part of this topic, and we have a separate part for the problem solving. Suppose we have two identical balls, say ball number 1 and we have here ball number 2, where ball number 1 is moving towards ball number 2 with a momentum that is equal to mass times velocity. If the shot is perfect, and of course, since these two balls are identical, when ball number 1 hits ball number 2, the momentum of ball number 1 is passed towards ball number 2, causing for ball number 2 to move with a speed v. Suppose we consider another illustration where we have here a bullet that targets this block that is hanging from the ceiling. When the bullet touches, or when the bullet targets this block and embedded with the block, they move together and raised at a certain height, which we may call as height y. This is what we call as conservation of momentum. In the absence of an external force, the momentum of the system remains unchanged. For any system in which all forces are internal, which means that there is no external force or there is no external influence towards the system, the net momentum of the system before and after the event is the same. Here, to illustrate the conservation of momentum, we have to consider collisions. There are three types of collision. We have elastic collision, which says that it's a collision in which there is no net loss in kinetic energy in the system after collision. Mathematically, if we have two objects A and B, we have the momentum of A initially times, we have momentum of A initially, this is mass times velocity, plus the initial momentum of object B, we have mb1 vb1 is equal to their momentum or the sum of their momentum after the event. So we have ma2 va2 plus we have mb2 vb2. These are simply their momenta. No? So this is pa1 plus pb1 is equal to, this is pa2 plus pb2. We also have this inelastic collision, or a collision in which the total kinetic energy after the collision is less than before the collision. So this is less than before the collision. And there is a special type of inelastic collision, which we call as completely inelastic collision, which says that an elastic, or this is an inelastic collision, where the two objects stick together after collision. An example of this is the bullet that is embedded in the block, where at first, before hitting the block, the bullet and the block are separated, but when the bullet hits the block, they become together. That is an example of completely inelastic collision. Another example is if this person is walking and there is a chewing gum somewhere here, and then that person stamped on this chewing gum and they move together, that is what we call as completely inelastic collision. So basically, we can describe the mathematics of this completely inelastic collision by just basing on the event. Initially, they are separated. So if we call these objects as object A and object B, we have object A, or the mass of object A initially times its speed initially. This is basically the initial momentum of object A. Plus, we have the initial mass or the initial momentum of object B. Okay, we have times the speed of object B initially. We have VB1. And this is equal to, since they have stick together after the event, so their masses have combined. So we have MA plus MB. And they are moving together with the speed V2. Here, okay, we have the choice if we will be putting a subscript on the masses, because obviously, in most cases, the masses are constant. If we have here mass of object A, we put here a subscript 1. And after the event, there is also a subscript, which is 2. But obviously, here we can see that MA1 is just equal to MA2. Or this is just equal to MA. We are just putting it this way for general or for generality or generalization of this equation, because basically there are some cases, very few cases, where the mass changed. But obviously, here we can just write MA1 equals MA2 equals MA, or MB1 equals MB2 equals MB. So these are the three types of collisions. There are other types of collisions, and that is the case where there is other phenomenon, or there are other phenomena that happens. For example, we have the explosion of particles. Now, when one particle collided with another particle and there is explosion, that is another type of collision. But basically, in this course or in this discussion, we will only be dealing with these three types of collisions. If you have questions, you may just comment your questions in our comment section.